Everyone, welcome to Baozi Training Leetcode solution. If you want the best marketing experience in North America, feel free to check us out at baozitraining.org, and also feel free to visit our tech blog, blog.baozitraining.org, where we periodically post any either Leetcode solution or system architecture design related articles. Okay, today we're going to talk about this problem, binary tree zigzag level order traversal. Essentially, it's giving you a binary tree. We want to output a list of if we select it to Java, a list of integers, in zigzag order, which basically from left to right 3, and then 29, and then 15, 7. So here's the solution. So essentially, it's a very simple problem, mostly implementation. Actually, honestly speaking, in interviews, I like to ask those kind of questions just purely for coding purpose. It's like, okay, we do know the candidate can code, and also can come up with different test cases. This one is very similar to level order traversal. Remember, in binary tree level order traversal, we just need a let's say a queue to hold the values. Exactly the same idea. So you can use a deck, a doubly linked list, or you can use 2 stacks because of this order thing. So I chose to use a deck, which is you can initialize a linked list, and it has the interface of you can either pull from first, pull from last, or you can add to the first, add to the last. Essentially, it's just like this. If it's from left to right, you pull the first. So if I show this kind of thing, at first it's from left to right. So you want to pull the first thing, which is you post the one out in my example. So this one is out. And then, so you're trying to add the last of the node, which is left and then right. So essentially is you put a 2 and a 3. So now the queue looks like this. And now you're actually reverse is from left to right. So now you're actually from right to left. What you want to do is you pull the last one. You pull the last one, you pull the 3, so this is to the result. So this is what you want. So 3 already is in the result. And then what you want to put it in is you want to add to the first, to the right one, add to the first, which is 7, and then you add first the left one, so 6. So essentially this will be 5 and 4 for doing exactly the same thing for 2. And then you are left to right again. So while you are left to right, you basically read from 4, 5, 6, 7. So it's purely implementation question. So there's also multiple ways to implement. I also implement in the 2 stacks way, but it's fine. The time complexity is O(n) because you visit each node once, and the space complexity is O(n) because we did use a deck, a doubly linked list. One thing I do want to point out is, for example, in some of the solutions I linked here, is as long as if you use let's say if you only want to use one queue, right? So when you call this method add to an index with a value in an array list, because at the underlying implementation is actually a array, right? So it's more like you have to copy over the code, versus in deck, whenever you add or pull, it's basically a linked list structure, so it's not doing that copy over thing. So this doesn't really makes this thing is like strictly O(n) because you're copying over the code in every add index value operation. Just want to call that out. If you want to implement that, I mean, in real coding, you can call that out too. Yeah, that's it. Thanks for watching. See you guys next time. Bye.